to begin tackling some of the questions in this exercise, first we call out the table of integral. This is it. Oops. Okay, and they'll be very useful later. So I think we're ready to do a few questions. But before that, let's look at a couple of properties of integral. The first one is this: if we have a sum of two functions, we can separate this two functions and write them as follow, as the sum of two integrals. So we just, instead of doing this directly, we can just integrate fx and then gx separately and then find the sum, and then that would be the same as doing this. And the other one is this: if we have a number, a scalar, usually we call that times a function, and this, remember, this k is a value. You can write the k in front of the integral, and then you can just perform the integrations, and at the end use times k. Okay, now let's look at this. Say here, we can treat this function as the sum of four functions. The first function, the second one x squared, the third one will be x, and the last one is a constant 2. So we write them like this. This is according to the first property, but instead of having just 2, but now we have 4. How about operators in between each one? So between x power 4 x squared, we had subtraction, minus, so we write minus. Here we have minus, minus, and we have plus. So we just write down plus. And according to this table, we'll be using this x to the power of n. Now if we integrate, we get x to the power of n plus 1 over n plus 1 plus c. So this x power 4 becomes 4 plus 1 over 4 plus 1. There is a little plus c 1 here. I do not write right now. I'll do that later. Minus x, so square, so it becomes cube over 3, and this is x is actually power 1, so you have x squared over 2. Just follow the formula, and then lastly this formula, if you integrate a constant k, you get kx. So we have 2, so we write 2x, and each of this integral actually produces a constant c, 1, c3, and c4. So we're going to find the sum of this, right, eventually. And instead of writing these 4 constants separately, we collect them and write as a big C. Right, so we don't need this anymore, and just simplify this. And that's your answer. Then let's look at one more. Let's try this. I can write this as follow. Again, right, this is using this later property we used earlier. Let's separate them. The second property here I mentioned, there's a k, right? This number 2, and put the 2 in front. Just worry about the ex, and of course, what is 1 over x squared? 1 over x squared, of course, is this. And finally, now look at the table. If I integrate ex, I get ex. So here I have 2 ex, and then this would be x plus 1, so I get -1 and hit -1. Don't forget the c, okay, and so you end up with 2e power x plus x to the power -1 plus c. Right, try to practice the other questions. Now moving on to this question 2. Just going to do a pen on find find y if dy dx is given. So dy dx is given here, 2x plus 3. That means the y is the integral of this expression, and so this would be 2x squared over 2 plus 3x. Do not forget the c, and there you have it, x squared plus 3 plus c, 3x. Now one way to check whether you actually got the right answer is by differentiating this your answer, and if you differentiate your answer you get 2x plus 3, c will be a 0, and yeah, just nice, exactly the same as the problem itself. I think I have time to do D also, so I will do it. And to make it more easy to integrate, I'm going to express them in this form, the exponential form, and okay, so means that y is to integrate this. Again, we use that little property, 2 prime is dx. This is our x dx, okay, -1, and so it's going to be at 1, so it's going to be 3 over 2 divided by 3 over 2 minus 2. This for x is going to add 1, negative half at 1, so you get half over half. Do not forget the c, and you should get 2 over 3 x 3 over 2, just simplifying, and about this is at minus 4 x to the power half plus c. Okay, now moving on, the one more, I think I'll do the question 4. This question 4 is very special because there is an initial condition given to you, f0 equals 3. Now what is the purpose of this condition? We will find out later. Just start with this, f prime x, I mean f prime x is 2x minus 1. So fx is the integral of this, and by now you should master integration after you've done a number of questions. Anyway, so it's x squared minus x plus c, and now we know the reason why the initial condition is given is this. We have the answer, but it's not enough because there's a condition given to you, and we may find the value of c by using this. This is 3, so the left hand side is actually x squared minus x plus c, means this equals 3. Also c is 3. And that means your fx is actually exactly, I mean, we know the value of c now is 3, so it's exactly this. Right, so I hope that you would try the other questions in this exercise, and I hope the videos are helpful to you.